Hello again. To continue from the last session where we stopped, let's pick up what is meant by SIS2. What is meant by system requirements analysis? First, we elicit the requirements, we understand the requirements, we gather the requirements. Now, here we process the requirements. Now, what is meant by this processing? What exactly does the word processing or system requirement analysis exude? The purpose of the system requirement analysis process is to transform the defined stakeholder requirements into a set of system requirements that will guide the design of the system. Understand this word carefully. Understanding the from stakeholder requirements, you are designing the system. Okay, so it is here that you actually design the system, whether it is in ECU, it may be as small as ECU or as big as a fighter jet. This is the exact step where you start the design of the system. Okay, step one, you say that I require a fighter jet, and step two, sys2, you start designing the fighter jet. What should the wingspan? What should be the payload? What should be the propulsion? What should be the thrust? What should be the fuel efficiency? All these things in the sys2 you start designing. Now let's touch upon what are the base practices. These base practices are very important, and I want all of you to pay a lot of emphasis on these base practices. And again, let me here emphasize one thing. I am not specifically mentioning about ADAS because once you master these base practices, you can uh, use these base practices in any system. Whether you are developing for a transmission control module or brake control module or door module or safety module, for whichever ECU, for whichever system you want to develop, you can clearly develop once you have command on these base practices. Just to give you an analogy, if you are a good batsman, you can be a good one-day cricketer, you can be a good test cricketer, and also you can be a good T20 cricketer. Likewise, once these base practices, if you absorb these base practices and once you have a thorough command on these base practices, whether you are developing for ADAS functionalities or any other module functionalities, it will be very easy for you. That's the reason I am first putting a lot of emphasis on this base practices. So what is meant by SIS2 base practice 1? Here, use the stakeholder requirements and changes to stakeholder requirements to identify the required functions and the capabilities of the system. Now, this word is very important. Understanding the capabilities and the required functions. Specify the functional and non-functional system requirements in system requirement specification. Again, here also understanding the functional and non-functional system. Now, let me again go back to the fighter jet example. What is meant by functional requirement? Flying from point A to point B, or traveling with certain number of missiles and destroying the enemy target is a functional requirement. Now, what is meant by non-functional requirement? Non-functional requirement is when the vehicle is not, the fighter jet is not flying, it should be thoroughly parked properly in a in a particular hangar, or this should be properly be cleaned. I mean, there should be a facility to uh, clean the aeroplane or lubricate the aeroplane or to maintain the airplane. I mean, maintenance should be feasible. There's no point in building a very beautiful product, but when it comes to monthly maintenance or yearly maintenance, it is not feasible. So that maintenance facilitation is a non-functional system. Okay, so understanding the both functional and non-functional system requirements is an important part of this base practice. Application parameter influence functions, capabilities are part of the system requirements. So what is this application parameter? Here, actually, the mathematics come into picture. You should have such and such a thickness. You should have such and such a flow rate. You should have such and such a temperature. You should work at such and such a temperature. All these things fall under this application parameters. For changes to stakeholder requirements to now, what is this SUP10? That is beyond the scope. So I want all of you to ignore this for now. Actually, for now, you please ignore it. Let's go to system 2 base practice 2. Structure system requirements. We have to outline the system requirements in a very structured manner. It has to be very organized. It should be very clear cut, which comes first, which comes second, which comes third. Again, going back to the fighter jet, first you start the ignition, then you start the runway, it goes running on the runway, then it takes off. All these requirements must be in a very organized, in a proper chronological manner, you should be outlined. Okay, so again, here by example, grouping to project relevant clusters, sorting in a logical order for the project. Understand this word carefully. Logical order for the project. Categorizing based on relevant criteria for the product. Now, what is meant by categorizing? I already told you, whether it is a functional requirement or a non-functional requirement, it should be clearly be categorized. And prioritizing according to the stakeholder needs. Again, especially when you are developing with the help of a uh, in uh, in agile, there is something called minimum viable project. Sometimes this minimum viable product has to be prioritized. What exactly is the need, what exactly is the priority? Okay, for example, if you're developing a electronic control unit for ADAS functionality, the they may have various requirements. They may have various requirements, but one particular ADAS requirement should meet 2025 ADAS requirement, and another requirement may need 2028 requirement. So what is the priority? Meeting the 2025 legal requirement is a priority. So you should meet that priority requirement. So here, that is where prioritizing the stakeholder requirements comes into picture. We must be very clear what is the priority. Now coming to SIS2 base practice 3, analyze the system requirements. Analyze the specified system requirements, including their interdependency, to ensure correctness, technical feasibility, verifiability, and to support risk identification, and analyze the impact on the cost, schedule, and technical impact. So I understand that's understood clearly. Bifurcating SIS2, SIS3 is very difficult, but there is a thin line between each and every one. Okay, there is a clear distinction between structuring and also analyzing the specified system requirements. We have to ensure in this step based practice, we ensure the correctness, we ensure the technical feasibility, we ensure the risk identification, and we also analyze the impact on cost, schedule, and technical impact. Understand this word cost, because all said and done we are doing business. There is a difference between research and engineering. Research does not involve cost, but engineering always involves cost. Understand this very carefully. That's the reason whenever you see the impact, whenever I talk about the impact, the first word comes into picture is cost. Now coming to base practice 4, analyzing the impact on the operating environment. Apart from the cost and technical feasibility, you analyze the impact on the operating environment. Identify the interfaces between the specified system and other elements of the operating environment. Okay, so identifying this interface is called base practice 4. What is meant by base practice 5? Developing the verification criteria. Now again, here it is very important and it is of paramount importance to identify the verification criteria. So when you develop a system, you clearly have to outline the use case and the test case through which you are going to develop a verification criteria. So for example, if at all I have a rotating shaft, let me give a very crude example. If I have a rotating shaft, will it sustain if I rotate it for 1000 rpm for 5 minutes, or will it sustain if I rotate for 2000 rpm for 8 minutes? So understanding this criteria is what is included in the base practice 5. Now coming to base practice 6, note 5. What is this note? Verification criteria demonstrate that a requirement can be verified with agreed constraints. This is very important. Now, as somebody who comes from a manufacturing background, and there has to be a clear-cut agreed constraints, because sometimes when you want to develop a particular component as a supplier, you may have a certain standard, and as a OEM, you may have a certain standard. And it is very important to ensure or to cherry pick what are the constraints which are common to both supplier and OEM. Okay, so this is where verification criteria comes into picture. Now understanding the bidirectional traceability, this is base practice 6. Now again I emphasize what is the purpose of traceability. So understand the bidirectional traceability. You should understand which component affects the result and which result can be traced back to the which component. So this is what is called established bidirectional traceability. And base practice 7 is ensure consistency. This is again, everybody who has been in any industry, whether it is a software industry or hardware industry, clearly knows that a software component or a hardware component must be churned out consistently, and it should have a same repeatability and reproducibility. And next base practice 8 is communicate agreed system requirements. Communicate the agreed system requirements and updates to system requirements to relevant parties. Base practice 8 is from here you clearly communicate the agreed system requirements. Once you gather the requirements in system 1 process, and from system 1 you develop the design requirements, and these design requirements are also clearly communicated. This is called the system 2 base practice 8. And what are the process outcomes? As a result of successful implementation process, a defined set of system requirements is established. And there is a slight overlap here actually. You may say that this is set of requirements has come to sys1 also. But again, there's a slight overlap. In sys2 also you revisit the system requirements. And again, your system requirements are categorized and analyzed. I clearly mentioned the various categorization, the functional requirements, non-functional requirements, the various design constraints, all these things are clearly outlined. The impact of the system requirements on operating environment is analyzed. As I already said, impact on the operating environment. When you say operating environment, it necessarily need not be the ambient atmosphere. It is even the environment of that particular component, the various components, the various interfaces through which to which it is interacting. Prioritization for implementing the system. I clearly mentioned what is my prioritization. Whether it's a functional requirement is priority or non-functional requirement is priority or the legal system is priority. All these things are clearly outlined. The system requirements are updated as needed. The consistency and bidirectional traceability are established between stakeholder requirements and system requirements. These words are extremely important. Consistency and bidirectional traceability, especially when you are developing a complicated system. Because during the end testing, if at all something goes wrong, instead of totally dismantling the entire system and trying to identify where things went wrong, if you have a proper traceability, you can pinpoint very easily where exactly things have gone wrong. Okay, and already explained whether it is things have went wrong during the system analysis, or things have went wrong during the architecture, or things have went wrong during the integration. All these things can be clearly outlined. The system requirements are evaluated for cost, schedule, and technical impact. Again, in case you think I am re-emphasizing, please understand this is a very extremely important word as far as business is concerned, and I am sure all of you agree with it. The system requirements are agreed and communicated to all affected parties. Again, this is very important. There's absolutely no point if you develop a particular design and it is not agreed by the end party. Okay, right. What are all the various work products? Here, please see this list here. Communication record, the review record, the change control record, the traceability record, analysis record, interface requirement specification, system requirement specification, verification criteria. All these things I already clearly explained to you in this session. And all these work products, I mean, we should have a proper documentation to store this information which we already verified, which we already noted. Okay, so with this I conclude this SIS2. Thank you.